वो लास्ट टॉपिक में हमने जो किया था उससे रिलेटेड हम न्यूमेरिकल करेंगे आज, ठीक है। तो देयर आर रिलेशंस लैम्डा इनटू न्यू इक्वल टू सी, देन E इक्वल टू एच न्यू और न्यू बार दैट इज वेव नंबर इक्वल टू 1 upon lambda and time period that we left, time period. So time period t, it is the time required by the wave to complete one wave, time required to complete one wave, time required to complete one cycle by wave, right? So time period is actually reciprocal of frequency. इससे related today we will do some questions, okay? So first question is, it is exercise question, that yellow light emitted from a sodium lamp, okay, Mansi is there, okay. Yellow light emitted from a sodium lamp has a wavelength of 580 nanometer. So calculate the frequency nu and wave number of the yellow light. तो देखो आपको वेवलेंथ दी हुई है लैम्डा 580 नैनोमीटर, आपको फाइंड आउट करना है एक तो वेव नंबर और दूसरा निकालना है फ्रीक्वेंसी, ठीक है ना। और देखो लैम्डा into nu that is equal to c and value of c is fixed, कितनी होती है 3 into 10 raised per 8 मीटर पर सेकेंड। दैट मीन्स जो फ्रीक्वेंसी है वो आएगी पर सेकेंड में जब वेवलेंथ होगी मीटर में। तो यहाँ वेवलेंथ है नैनोमीटर में, तो पहले इसको मीटर में कन्वर्ट करोगे और फिर लैम्डा फाइंड आउट करोगे, और जो वेव नंबर होता है दैट इज इक्वल टू रेसिप्रोकल ऑफ वेवलेंथ। ये दो क्वेश्चन करते हैं पहले, ठीक है। चलो फर्स्ट क्वेश्चन, तो फर्स्ट क्वेश्चन इज yellow light emitted from a sodium lamp has a wavelength of 580 nanometer. Calculate the frequency and wave number of the yellow light. So we use this formula, you know, lambda into nu equal to c. C value is fixed, that is 3 into 10 power 8 meter per second, and wave number is 1 upon lambda, reciprocal of wavelength. So first of all, frequency is equal to c over lambda. C is 3 into 10 power 8 meter per second, divided by wavelength. So wavelength is actually 580 nanometer. So that should be 580 into 10 raised per minus 9 meter, because 1 nanometer is 10 raised per minus 9 meter. So it is 580 into 10 raised per minus 9 meter. तो कितना वैल्यू है? वैल्यू इज इट इज 5 पॉइंट, कितना है वैल्यू? किसी ने फाइंड आउट नहीं किया, क्योंकि देखो इसको 5 पॉइंट क्या 0.58 कर दोगे अगर, है ना, तो 3 ऑलमोस्ट 5 ही आएगा ही, है ना, और ये कितना हो जाएगा 14, 10 raised per 14 per second. Per second means hertz, so that is 5.17 into 10 raised per 14 hertz. क्योंकि 1 hertz is 1 cycle per second, right? अब दूसरा क्वेश्चन था वेव नंबर, so that is 1 upon lambda. Lambda is 580 into 10 raised per minus 9. वेव नंबर ऐसे आएगा तो इसकी वैल्यू आएगी 1.72, ठीक है। ये 0.5 करोगे तो इनटू 10 रेज़ क्या हो जाएगी 6 पर मीटर। समझ रहे कैसे? इसको 0.58 कर लो, अगर ये 1/0.5 होता तो यहाँ 2 आता, 0.5 करोगे तो 3 डेसिमल प्लेस है ना, तो ये 10 की पावर क्या हो जाएगा -6, ऊपर जाके 10 की पावर 6, है ना। अगर ऑब्जेक्टिव क्वेश्चन हो तो ये वैल्यू लेस देन 2 होगी और ये 10 की पावर 6 पर मीटर। फाइंड द एनर्जी of each of the photons which corresponds to light of frequency 3 into 10 per 15 hertz. So first question where frequency is given to you, that is 3 into 10 raised per 15 hertz, and you know according to Planck's equation, Planck's theory, क्या होता है E equal to h nu, and what is the value of h? 6.626 into 10 raised per minus 34, right? Joule second into frequency is 3 into 10 raised to power 15 per second. Hertz is per second. So second per second cancel means answer is in joule. बोलो तो वैल्यू इज, जल्दी करो यार, 1.988 into 10 raised per minus 18 जूल। जो आंसर वो लिख रहा हूं मैं, है ना, राउंड अबाउट यू कैन राइट इट एज 2 into 10 raised per minus 18 जूल। So this is question number 1 of first part of question number 2. Then second one, energy of each of the photons which have wavelength of 0.5 angstrom. See, energy is equal to, you know, h nu, but lambda is given, so nu is c over lambda, so it is hc over lambda, right? Now value of h, you know, what is lambda? It is 0.5 angstrom, that is 0.5 into 10 raised per minus 10 meter. Convert angstrom into meter because all should be in SI units. तो ये हो जाएगा h is 6.626 into 10 raised per minus 34 joule second. What is C? 3 into 10 raised to power 8 meter per second divided by 0.5 into 10 raised to power minus 10 meter. See, meter cancel, second per second cancel. So answer is in joule. 0.98 into 10 raised to power minus 15 joule. Question is calculate the wavelength, frequency and wave number of a light wave whose period is given. When period is given to you, that is time period is given 2 into 10 raised to power minus 10 seconds. From time period you can calculate frequency. From frequency you can calculate wavelength. From wavelength you can calculate wave number. Just do it by your own. ये आप करोगे आप. So time period is given. So from time period we know frequency is equal to 1 upon time period. So it is 1 upon 2 into 10 raised to power minus 10. That is 1 upon 2 into 10 raised to power 10. So it is 10 by 2 into 10 raised to power 9. Means 5 into 10 raised to power 9 seconds. Okay. Then wavelength is equal to C over nu, because nu into lambda is equal to C. So C is 3 into 10 raised to power 8 meter per second and frequency is per second. So 5 into 10 raised to power 9 per second. So that you have calculated. The value is 6.0, because if we take it as 30, so it becomes 5 6 are 30, so 10 power minus 2 meter, so sorry per second cancel, so answer is in meter. Then is wave number. So wave number is 1 upon lambda. So 1 upon lambda is 6.0 into 10 raised to power minus 2. So we have to calculate number of photons of light with a wavelength of 4000 picometer that provide 1 joule of energy. Means total energy provided is equal to 1 joule. So you know total energy is equal to N H nu, where N is number of photons, N is number of photons, and H nu is energy of one photon. Energy of a photon. So that means to calculate number of photons, total energy is divided by energy of one photon. And what is the energy of one photon? H nu. Okay? That is, it is equal to E total over, you can write E, energy of one photon. Right? And that is equal to H nu. But wavelength is given to you, right? So to calculate E, total energy is 1 joule. E is H nu, that is equal to Hc over lambda. Lambda is given to you 4000 picometer, and 1 picometer is how many meters? 10 raised to power minus 12 meter. Your first task is to convert nanometer, angstrom, picometer into their basic unit, SI unit, meter. Okay, so it is actually 4 into 10 raised to power minus 9 meter. Okay, so energy E is equal to H, it is 6.626 into 10 raised to power minus 34. E, energy speed of light, 3 into 10 raised to power 8 meter per second. This is joule second, this is meter per second, and lambda is 4 into 10 raised per minus 9 meter. So meter cancel, second per second cancel. This energy of one photon comes in joules, 4.97 into 10 raised to power 34 minus 17 joule. This is energy of one photon. This is total energy. So number of photons n, that is number of photons of light with wavelength 4000 picometer that provide 1 joule of energy, that is equal to total energy divided by total energy divided by energy of one photon, right? So total energy is 1 joule and energy of one photon is 4.97 into 10 raised to power minus 17 joule. So number comes out to be, say, 1 upon 4.97. 1 upon 5 means if it is point here 10 to minus 16, so it is 2 into 10 raised to power 16. 7, you can take it as 5. Okay, then it is 2 into 10 raised to power 16. So these are the number of photons of light which provide energy of 1 joule. Okay, electromagnetic radiation of wavelength 242 nanometer is just sufficient to ionize the sodium atom. Calculate the ionization energy of sodium in kilojoule per mole. Answer should be in kilojoule per mole. Ionization means, or ionization energy means sodium gas, sodium in gaseous form. Okay, sodium gas to give sodium positive gas plus electron. So it is written electromagnetic radiation of wavelength 242 nanometer. It is just sufficient. What is the energy possessed by the photon? One photon can eject one electron. Keep in mind, एक इलेक्ट्रॉन निकालना है तो एक फोटोन चाहिए हमें, उसकी एनर्जी के बराबर होने चाहिए. That is just sufficient to ionize the sodium atom. आयन बनाना है सोडियम का. So one electron is removed. So to remove this ion, that energy is called ionization energy. What is ionization energy? Amount of energy required to remove an electron from the isolated gaseous atom. Why this isolated and gaseous atom? Because that is free from all types of interactions. Gaseous atom is free from attraction of other atoms, right? So sodium should be in gaseous form, sodium positive gas plus electron. So this energy which is used to remove the electron, that is called ionization energy. Okay, so that is energy of one photon. So first I write the definitions. Okay, first, what is ionization energy? Required to remove an electron from an isolated gaseous atom. This isolated and gaseous atom means the atom which is free from all types of attractions or repulsions, right? So that is gaseous. Okay, so ये जो energy होगी, that is called ionization energy. Okay, and how much energy is required to remove the electron? It is just sufficient. This wavelength is just sufficient to ionize this sodium atom. So one photon can eject one electron. Eject means to remove. One photon can eject one electron. What energy should be in per mole? Means energy is required for 1 mole of electrons. Okay, so first of all we calculate energy of one photon. That is sufficient to remove one electron, right? So energy of one photon, that is h nu, and that is equal to hc over lambda. Lambda is 242 nanometer. So lambda equal to 242 nanometer. That is 242 into 10 raised per minus 9 meter. Right? So just put the values. It is 6.626 into 10 raised per minus 34. It is 3 into 10 raised per 8 meter per second divided by 242 into 10 raised per minus 9 मीटर. मीटर से मीटर कैंसिल, सेकंड से पर सेकंड कैंसिल, जूल में आंसर आ जाएगा. बोलो कितना आया? वैल्यू लिख रहा हूँ 8.21 into 10 raised per minus 19 joule. This is energy of one photon. So this is energy required to remove one electron. Okay. अब हमें क्या करना है, आयोनाइजेशन एनर्जी पर मोल, ये है आयोनाइजेशन एनर्जी, ये है, ये भी आयोनाइजेशन एनर्जी है, बट इट इज जूल पर एटम, एक एटम के लिए हुआ ना ये एनर्जी, ठीक है ना। ओके, तो अब हम पर मोल में पहले फाइंड आउट करते हैं, है ना। आयोनाइजेशन एनर्जी ऑफ 1 मोल ऑफ एटम्स कितनी हो जाएगी, 8.21 इंटू 10⁻⁻19 जूल इंटू 6.022 इंटू 10⁻23, कितना बुगेट नंबर पर मोल, है ना। तो वैल्यू आ जाएगी 6.023 भी लेते हैं, 22 भी लेते हैं, तो 494 इंटू 10⁻³ जूल पर मोल, ठीक है। तो किलो जूल में कितने आ जाएगी, 494 किलो जूल पर, समझ गए। क्योंकि देखो उसने ऐसा नहीं लिखा था कि एक मोल के लिए निकालो, बट उसने यूनिट ऐसे दे दी है, क्या लिखा उसने कि आयोनाइजिंग एनर्जी ऑफ सोडियम एटम इन किलो जूल पर मोल, ऐसा लिख के दे दिया। तो इससे क्लियर हो गया कि एक इलेक्ट्रॉन के लिए तो ये है, एक सोडियम एटम के लिए तो ये है आयोनाइजिंग एनर्जी, बट हमें किसमें चाहिए, एक मोल की। तो एक मोल के लिए हमने एवोगाड्रो नंबर से मल्टीप्लाई किया, एक एटम के लिए जितनी होगी तो एक मोल के लिए कितनी होगी, मल्टीप्लाइड बाई एवोगाड्रो नंबर। तो जूल में आंसर आ गया पहले, पर आंसर निकालना था किलो जूल पर मोल, तो 10⁻³ जूल इज 1 किलो जूल, सो ये किलो जूल पर मोल में आंसर आ गया अपने पास। गॉट इट। सिक्स्थ क्वेश्चन, राइट डाउन। सिक्स्थ क्वेश्चन इज a 25 watt, आई थिंक आप ये पढ़ के आए होंगे लोअर क्लास में, वॉट क्या होता है ना। 25 watt बल्ब एमिट्स मोनोक्रोमेटिक येलो लाइट monochromatic means which has only a single wavelength. Yellow light has range of wavelengths. Okay, polychromatic light means which has a range of wavelengths, and monochromatic means which has single wavelength. Only one wavelength is there. Okay, so a 25 watt bulb emits monochromatic yellow light of wavelength. What means power? Yellow light of wavelength (0.57 micrometer). Calculate the rate of emission of quantum of rate of emission of quantum per second. Okay, chalo, actually watt means joule per second, how much energy is released per second, that is called watt. So it is actually 1 watt is 1 joule per second. 1 watt is equal to 1 joule per second. Okay, so it is 25 joule per second. So total energy जो है that is 25 joule per second. So आपको फाइंड आउट करना है कि कितने फोटोन क्वांटम इज लाइट के केस में इसको क्या बोलते हैं, फोटोन। तो कितने फोटोन पर सेकेंड एमिट हो रहे हैं वो फाइंड आउट करना है। सिंपली वही क्वेश्चन है पीछे वाला, टोटल एनर्जी इज 25 जूल इन 1 second and calculate the energy of one photon, divide them, we get number of photons emitted per second, right? Because this is the total energy emitted per second. Just do it by your own. 25 watt means total energy which is emitted is 25 joule per second. Okay, and energy of one photon, that is equal to hc over lambda. So lambda here is 0.57 micrometer, means 0.57 into micro means 10 raised per minus 6 meter. Is it visible? Yes. So just put the values. 6.626 into 10 raised per minus 34 joule second. C 3 into 10 raised per 8 meter per second, and divided by 0.57 into 10 raised per minus 6 meter. Again meter, second per second, so answer should be in joule. So energy of the photon comes out to be, yes, anybody? It is 3.487 into 10 raised per minus 18 joule. Okay, now to calculate rate of emission of quantum per second, rate of emission of photon per second, that is equal to total energy emitted per second divided by energy of one photon. So total energy emitted per second is 25 joule. Okay, and energy of one photon 3.487 into 10 raised per minus 18. So what is the value? It comes out to be, it is joule per second and it is joule. So value comes out to be 7.17 into 10 raised to power 19 per second. That is the answer. Okay, same question, only it is rate. In that case, that is number of photons in 1 joule that we have calculated. Same in the case here, it is number of photons emitted per second. It is actually number of photons, but number of photons emitted per second. Right? Mansi, be regular in the class.